Good morning, everyone. I'm Aishwarya. I'm working as an assistant professor in the Department of EC at Emmanuel Arasa JJ College of Engineering. So today we are going to see a new topic, real-time operating system, which is commonly known as RTOS. So let's get into the section. So an RTOS is like a traffic controller for task inside a computer or device. So it makes sure important jobs happen exactly on time without any delays. So all the important jobs inside a system or a computer should be done properly without any delay. So that without any delay, the proper task should be done on time. So that should be controlled by a traffic controller, and that traffic controller inside the computer device is called as a RTOS. Okay, so RTOS is nothing but a special operating system that makes sure critical task happens exactly when they should be needed without any time delay. Okay, that is called as RTOS. So now let's begin with the types of RTOS. There are three types of RTOS, that are hard RTOS, soft RTOS, and firm RTOS. So the hard RTOS is absolute deadline. It has absolute deadline, and the soft RTOS, they have flexible deadline strictness, and firm RTOS has moderate deadline. So the hard RTOS impact of missed deadline. If the deadline is missed, so what happens in the RTOS means the system will totally fails. But in software RTOS, the performance degrades, means the effective performance can be affected. Then in firm RTOS, if the deadline is missed, then the output is useless. System continues without any problem, but the output may be useless. So examples for hard RTOS is pacemakers, flight control. So you know the flight control, right? If any problems occurs in the controlling of the flight, what happens? System totally fails. That what? Then soft RTOS examples are multimedia, telecom, communication, things like that. Then firm RTOS, the example is robotics and automation. If something happens unusual things, so the robotics, what happens? The output may be useless, more or less useless, but the system actually happens, right? The robot may work. So next is functions of RTOs. There are some types of functions. They are task scheduling, interrupt handling, multitasking, intertask communication, resource management, synchronization, error handling, real-time clock management. So these are the functions. So what is the basic functions and the examples for each functions? So task scheduling is nothing but it runs the task by priority. Many tasks will be done at the same time, but the system knows which task is the priority task, and that runs as the first. So the example is airbag development in car. For when an accident happens, what is the first priority? The airbag should be deployed, right? So that's all. Interrupt handling. A response instantly to events. So that is sensor alerts in robots. If robot senses earthquake or some type of temperature differences, they senses that immediately even in between the works they are doing. So that is interrupt handling. Again, multitasking runs multiple jobs effectively. One time, many jobs can be run effectively. That is engine plus dashboard control in vehicles, right? Again, inter-task communication shares data between tasks. Two tasks are done, so the data should be transferred for two tasks. It should share that, right? That is medical monitor sending readings. Again, resource management is allocate CPU, memory, input, output data is everything. That is flight control system. For flight control system, all these all these resources should be used and managed effectively, right? Yes. Again, synchronization means coordinating tasks safely. Many tasks will be done at the same time. They should be coordinated properly and safely. That is in industrial automation, right? That is, for example, in industry, if a part is manufactured, it should be aligned, it should be quality checked, quantity checked, then it should be coming in that conveyor belt, then it should be packaged. Everything should be done in a coordinating manner, right? That's what. Then error handling maintains stability. Okay, that is without any error, the output should be maintained very stable. So that is telecommunication switching systems, it is used there. Then real-time clock management, that is nothing but it executes timed task. That is pacemaker pulse timing is given here. That is for pulse making. For the pulse, there should be a certain time, right? That within that certain time, it should do that particular jobs. That's the functions of this RTOS. Again, applications. There is modern telecommunication system, it is used. Military applications, it is used. Satellite systems, it is used. Then again, network switching and control systems, it is used very randomly. So RTOS is a very important thing in use in all these applications. Okay, so thank you. I hope you all understand what is RTOS. If you have any comments, doubts, just comment in the just comment it. Okay, thank you.